Hi, everyone. We are happy to have you all here. And to begin with, I'd like to introduce you to the Director of UCAR Community Programs, Scientific Programs and Services Center, and the Director of CPAESS, Hannah Moriello.
Welcome, everyone. We are delighted to have you attend our CPAESS Discovery Seminary Series. This series began to share the impressive breadth and depth of the research from CPAESS scientists who study the entirety of Earth system science. We have scientists who do everything from explore ocean depths, to fly into hurricanes, to take critical measurements, to heliophysics, modeling coronal mass ejections, to those who unravel the mysteries of the Arctic. And we want to share this with the public, the INCAR UCAR community, and our many colleagues at universities across the globe. Just to orient you all, we are using Slido so that you can pose questions for our speaker, which you can type in at any time during the seminar. The Slido window is located below the presentation screen. Do not panic if you do not see your question pop up, as we are holding questions until our speaker completes their presentation. Questions will be revealed later during the Q&A portion of the seminar. It is my sincere pleasure to introduce to you today's speaker, Phillip Hartmeyer. Phil is a marine archaeologist at CPAESS, partnering with NOAA Ocean Exploration. Before joining CPAESS in 2022, Phil served as a maritime archaeologist at NOAA Thunder Bay Marine Sanctuary, where he conducted archaeological and historical research to discover, interpret, and protect cultural resources using advanced digital imaging techniques, marine remote sensing, and scientific diving. He has a Bachelor's of Arts in Archaeology from St. Mary's College of California, a Master's in Maritime Studies from East Carolina University, and is a registered professional archaeologist. Please join me in welcoming Phil. Thank you.
Thank you so much, Hannah, for the kind introduction. And it's a pleasure to be invited to share a little bit about marine archaeology in NOAA's Office of Ocean Exploration. Formally, our office is known as NOAA's Office for Ocean Exploration and Research, but it's shortened to NOAA Ocean Exploration, which you'll hear throughout this presentation. By leading national efforts to explore our oceans and making ocean exploration more accessible, NOAA Ocean Exploration is filling our gaps in basic understanding of U.S. deep waters and the seafloor, providing critical deep ocean data, information, and awareness needed to sustain and accelerate the economy, health, and security of our nation. Since the earliest days, NOAA Ocean Exploration has been a substantial source of public funding for the discovery and protection of shipwrecks and other submerged cultural resources that open windows into the past to help us better understand our shared history. And I want to start off with this short 1-minute video showcasing the variety of things that ocean exploration does. Of course, marine science is largely a visual field, and there will be several videos throughout the presentation that I hope you can get a little bit from on what we do at Ocean Exploration and how we can support. This video was produced and edited by CPAESS scientist and educator Rachel Goldbrough.
Good morning from the NOAA Explorer.
Vehicles are on their way down.
This is your geology science lead.
We came into auto position. Are you ready to take back ship control?
I am ready.
Copy that.
Actually, 115 meters at 1.8. Go ahead, Dempsey.
Hey, we are in auto position and we're passing control back to the bridge now.
Copy.
a great short clip and collection of videos that really describes the breadth of the mission, which is going to lead us to the first part of this conversation, really, which will introduce us to what ocean exploration does, who we are, and then certainly transitioning for the second half of the presentation to underwater cultural heritage and how marine archaeology fits into this this large, broad mission. And really, for NOAA Ocean Exploration, it started in the year 2000, where it was established that a national program for ocean exploration really needed to be founded. You know, there have been many calls for defining exploration, mapping, and characterization, and indeed they're important. But there's also many different definitions that have been applied throughout the years for each of these terms. So the office draws the definition of exploration as a foundational part of our mission from the President's Panel for Ocean Exploration, which defines exploration as discovery through disciplined, diverse observations and the recording of the findings. An explorer is distinguished from a researcher by virtue of the fact that an explorer has not narrowly designed the observing strategy to test a specific hypothesis, where a successful explorer leaves a legacy of new knowledge that can be used by those not yet born to answer questions not yet posed at the time of the exploration. This new knowledge may have immediate beneficial applications, of course, in answering the needs of contemporary ocean scientists, national resource managers, educators, and industries. In response, the office was formed 1 year later in 2001. And of course, we depend on the ocean to regulate weather and climate, sustain a diversity of life for maritime shipping, national defense, for food, energy, medicine, and other essential services to humankind. We know some things about the ocean, including, perhaps most importantly, that it is changing rapidly. But we know little about the processes and connections that provide goods and services to which humanity depends. And of course, the first step towards increasing that understanding is to explore. We need to know about the deep ocean specifically, which is a big focus for our office. Its geology, flora, fauna, connections, heritage among regions, if we are continued to benefit from the vital service that the ocean provides. It's a national imperative. That much is clear. And it was just this century that our government began to place an emphasis on ocean exploration specifically. Today's activities are largely driven by the National Strategy for Mapping, Exploring, and Characterizing the United States Exclusive Economic Zone, NOMEC for short, released in June 2020. The National Ocean Mapping, Exploration, and Characterization Council was subsequently established to help achieve the drivers within the NOMEC strategy that outline goals and steps that U.S. federal agencies can take to map, explore, and characterize our coasts and oceans. And the EEZ, or the Exclusive Economic Zone, is a massive place. More than 3.4 million square nautical miles of ocean. The EEZ is larger than the land of all 50 states combined, and it's one of the largest EEZs on the planet. It contains naturally a vast array of natural and cultural resources such as seafood, critical minerals, medicine, and areas of significant ecological and conservation value. But despite the importance of these resources, certainly to the health and security of the United States, only about 48% of the EEZ has been mapped, and significantly less has been fully characterized, meaning that these resources remain poorly understood and undefined, including the presence of significant underwater cultural heritage. There are several other driving pieces of legislation that do inform ocean exploration's mission, but NOMEC has been a very large driver and certainly at the top of the list. So we have this office. It's established to increase our knowledge and ability to explore this vast ocean that falls under United States territories and EEZ. How do we do it? What exactly are we going to do out there? And there's a couple main items here that are worth noting. Principally collecting high resolution bathymetry in areas with no or low quality data. Bathymetry is seabed topography, if you will. which sort of leads us to our abilities to identify, map, and explore the diversity and distribution of benthic habitats and resources, investigate deep ocean biogeographic patterns and connectivity, and collect better data to better understand the characteristics of the water column and the fauna that live there in that sort of transitional space. And lastly, of course, the data acquired to be able to support priority science and management needs. But at the very beginning, at the very bottom, right, is mapping. And ocean mapping is the foundation for exploration. The national strategy calls for mapping waters of the US EEZ deeper than 40 meters by 2030. And here's where we're at. 52% of all US ocean, coastal, and Great Lakes waters are unmapped. That's as of January 2022. NOAA Ocean Exploration operates primarily in waters deeper than 200 meters. That's the lane that ocean exploration generally swims in, with some really notable exceptions, but that's primarily the focus. And as you can see, there's a lot left to be done, especially in the Pacific. If you look at this map that should be on your screen, this is a mapping gap analysis that really helps inform mission planning for ocean exploration scientists and operations teams to identify areas of the most need, places that have the least bottom line map that of course correspond to other ocean science priorities. Places like the Northwest Pacific, Northern California, Oregon, and Washington, 20% are unmapped. Pacific remote islands in Hawaii, 48% unmapped. Alaska, 69% is unmapped. It's a lot to do. And there's many ways to do it. And I want to introduce you to NOAA ship Oceanus Explorer. It's a primary platform utilized for ocean exploration's mission execution. It's 224 feet long, and it's the only federal vessel dedicated to ocean exploration for the purpose of discovery and the advancement of knowledge about the deep ocean. Missions include, of course, seafloor mapping, site characterization, reconnaissance, advancing technology, education, and outreach. Oceanus Explorer houses a dual-body, remotely operated vehicle system that's capable of diving to depths of 6,000 meters and is equipped with a suite of sensors used to characterize the deep ocean. The ROV, the principal ROV you can see here, Deep Discoverer, is then is tangoed with its lighting sled and tender ROV, which is just out of the picture on the left. That's the ROV Sirius. And these ROVs are present on Oceanus Explorer as a primary platform for our deep water characterization work. Daytime ROVs with Deep Discoverer are broadcasted live to the ship's VSAT system. That's the golf ball looking array on Oceanus Explorer midships. Where at night, Oceanus is busy mapping uncharted ocean floor with acoustic remote technology. And of course, cutting edge marine science technologies are vital to mission success. Deep ocean mapping happens by a variety of geophysical and acoustic sensors that are mounted not only to the hull of Oceanus Explorer, but also on tethered systems like the ROVs and autonomous vehicles. Acoustic sensors are certainly the most commonly used for mapping, and they work by emitting sound at specific frequencies and recording the time that it takes for that sound wave to bounce off the ocean floor. And of course, also noting the strength of that return, which can inform substrate classification through CMEX and other avenues to identify substrate type. And of course, this data is visualized in different ways, including here on the bottom left. You can see an image that was generated with a synthetic aperture sonar system that was part of a technology demonstration hosted on Oceanus Explorer. Another way that ocean exploration is helping foster and develop and advance ocean exploration via private industry partnerships and ways to observe, help, and inform R&D for the latest and greatest technologies that are used in this realm. So that's the overview, right? That's ocean exploration in a nutshell from the forest level. And certainly there's a lot to unpack on what happens in deep water and what we find. And that's where we're going to focus in on something close to my heart, of course, certainly as a marine archaeologist, underwater cultural heritage. So I'd like to introduce a few case studies of projects that ocean exploration has been involved in. Some of these projects you may have seen on your own across the news, but giving you an idea certainly of really the power of partnerships and certainly where ocean exploration fits in with the marine archaeology community, and then transitioning to a whole other way that our office helps advance marine archaeology through our grants program. So kicking off with an exploration expedition in 2012, 2013. This was in the Gulf of Mexico, where this discovery came about because as federal agencies, our partners at the Bureau of Ocean Energy Management and the Bureau of Safety and Environmental Enforcement oversee and issue permits for oil and gas exploration and development on the Gulf of Mexico outer continental shelf. And under the National Historic Preservation Act of 1966, BOEM and BESSE for short are required to take steps that contribute to the preservation of sunken historic and archaeological properties. The oil and gas industry must follow specific BOEM guidelines for conducting surveys of the bottom using remote sensing instruments like side scan, magnetometers, multi-beam, before they are permitted to undertake activities that disturb the seafloor. As a result of intense oil and gas exploration in the Northern Gulf, more than 600 shipwrecks or potential shipwrecks have been located mostly through these surveys. And this is where a lot of the synergy between these agencies really shines and a lot of work gets done. In April 2012, NOAA Explorer conducted the first reconnaissance of shipwreck site 15577 in the Gulf of Mexico. This was first identified as just one of those targets in 2011 during a shell oil survey. And this brief ROV dive made a truly exciting discovery that will certainly contribute to our understanding of really turbulent period of American history as nations were being formed and the Gulf of Mexico was really opening up to global trade. And based on what we found, what we saw, shipwreck appears to be an undisturbed early 19th century wooden hulled sailing vessel, about 84 feet in length, 26 feet in beam, sitting in about 1,300 meters of water. Follow-up research was completed off the exploration vessel Nautilus with Ocean Exploration Trust and subsequent dives on NOAA Explorer. And a project like this really can't happen without our partners. And in this case, the primary partners being the Meadows Center for Water and the Environment at Texas State University, of course, NOAA's Ocean Exploration, NOAA's Office of National Marine Sanctuaries, Bureau of Ocean Energy Management, the Bureau of Safety and Environmental Enforcement, and our partners at the state, the Texas Historical Commission. And what we found was interesting, really a snapshot in time to the early 19th century sailing experience. There's artillery that's on board that sheds light on armament present on 19th century open ocean packets. What you're looking at is likely a 12 or 18 pound long gun that was likely mounted on the deck based on the fragments of its gun carriage still connected as it sits on top of the pile. Really describing, just a pretty wild experience to be sailing in that time where, shipwrecks largely wreck and degrade top down. So, a long gun like this sitting on the top of the pile with remnants of its gun carriage still attached certainly suggests that it was mounted on deck. Imagine the sailors that were really pushed to be familiar with these weapons, with disaster and potential piracy looming just about anywhere they were operating. So pretty wild to see some of these artifacts. Other diagnostic artifacts speak to additional experiences of the sailor, including sand clocks you can see here on the right-hand side of the slide. These were used for speed calculations. They're often known as sand glasses, but they were used as timers for the chip log line, which was trolled after the vessel, and it was timed to determine the vessel's speed for the navigator. So in use, a line was knotted at regular intervals and attached to the ship log, and after deploying, a sailor counted the number of knots passing through his hand over a given length of time, which was measured by the sand clock. So vessels of this period, right, they carried sand clocks timed to various increments, 28, 48, 60 seconds. And these are just 2 of the 5 sand clocks so far found on the shipwreck. And it's important to note, you know, a lot of these artifacts are really unique and certainly difficult to find in shallower water, certainly in conditions that are accessible by scuba diving. So, you know, researching and doing work in deep water has a lot of benefits, and finding intact sand glass is certainly one of them. Other diagnostic artifacts found on site include remnants of the compass shown here, including the compass card right in the middle. That's a little covered in silt, but you can imagine 4 cardinal directions, you know, and a navigator sitting above that binnacle, navigating, you know, this open ocean packet around the Gulf of Mexico. Bottles were found whose individual sizes and visible contents perhaps suggest that they were used as part of the ship's medicinal chest. There's a lot going on here, right? And that's what I'm hoping to share. What you'll take away from is there's so much to unpack on an artifact assemblage like this, and to remember that there's several of these vessels very nearby each other suggests perhaps this was a significant weather event that brought several of these to the ocean floor. But really, these artifacts jump out of the screen quite easily. Moving on to my second case study on marine archaeology as a part of NOAA Ocean Exploration. This takes us to a cruise in 2016, the deepwater exploration of the Mariana Islands. And this is a whole different history, right? Where Tinian Island was captured in 1944 as part of the United States island hopping strategy. And this became really one of the largest air bases during the conflict. And it was a center for B-29 operations. Tinian is roughly 1,400 miles from both the Philippines to the west and mainland Japan to the north. So the introduction of the B-29 in 44 featured, of course, many advanced technologies, and it gave America the identified capability to carry out long-range bombing missions against mainland Japan, often traveling more than 3,000 miles round trip. And that was really pointed to the way that the Pacific theater was going to conclude, was reaching mainland Japan. And the B-29 was designed just for that. And many of these planes departed from Tinian's North Field, which was only about 5 miles from the island of Saipan, just across the Saipan Channel. And really, this is at the tail end of the war, between late 44 and the end of 1945, several B-29s flying from the North Field suffered mechanical difficulties or other problems, really, and crashed in the channel for a variety of reasons, or off the opposite side of the island. It's unclear really how many were lost, but certainly about a dozen in this larger area were lost, with quite a bit more losses in the larger island chain. So, you know, fast forward to April 2016, during leg 1 of the expedition, OceanS Explorer mapped around this north end of Tinian Island using the ship's multi-beam. And the seafloor on the west side of the island proved to be rugged, and it was difficult to find potential targets based on coral heads, rock outcroppings. So efforts were refocused on the channel between the islands. And I want to share this short video with you to give you a sense on what we found.
We are broadcasting to you live today from the NOAA ship OceanS Explorer. So Tinian and Saipan served as major air bases during the final year of World War II, and there were B-29 bombers flying long-range missions at that time. Many aircraft were lost on takeoff and landing due to mechanical problems. The lost aircraft have great significance to American history. but none of the B-29s that crashed in this area have ever been discovered or explored. So this dive that we're doing today would provide the first information on aircraft or aircraft wreckage resting in the deep water of the channel.
Essentially what we're seeing here is the B-29. So we're looking at the left wing here, set the airplane's upside down.
Do you think that's evidence of an engine fire? I have seen damage like this on other wrecks where there was engine fires. That's why I was asking. That metal panel that we're looking at right now has large spots of pitting corrosion. There's holes as if it had melted.
There was an engine that was designed very quickly, and so they easily overheated, and a lot of pilots were very reluctant to fly the airplane.
So what you hear in the background of some of these, onboard short media clips are the voices of shore-based scientists that are collaborating on the mission in real time. One of the most incredible parts of working with ocean exploration is that ability to connect and network with scientists across the planet who are able to, using the ship's VSAT system, collaborate and in real time be a part of group chats of the discovery of the exploration, be a part of the video, narrate what we're seeing. And so we're tapping into expertise that's so much greater than our own. And that only makes these explorations that much stronger and more powerful and more relatable. And of course, this particular discovery represents an important symbol, of course, in America's final push to end the war. And is of interest to management groups and others working to identify crash sites for the families of lost servicemen. In total, there's over 400 reports of B-29 losses in the Pacific, 70 of which are in that immediate area, and unaccounted for crew associated with these losses amounts to 53 persons. It's a humbling opportunity to partner with agencies whose mission it is to locate, identify, and return fallen soldiers from foreign wars, including Project Recover, Task Force Dagger, the Department of Defense POW, MIA Accounting Agency, and others. A couple stills from the B-29, including some archaeology site plans and data products created from the dive. Of course, a hand-drawn map based on video, and the photogrammetric 3D model created by overlapping stitched visual images collected by the ROVs during subsequent dives to the site. So all of this data is able to be shared with the public and certainly increases our knowledge of aircraft operations and just the Western Pacific theater in general. Speaks to a lot of the important history that gets to be remembered in this particular way via this discovery. And fast forwarding another couple years, actually to just a few months ago, 2022, NOAA Explorer annually conducts an ROV mapping, an ROV shakedown and ship mapping expedition, testing all systems. And target was identified by our partners at the Bureau of Ocean Energy Management, who were made aware of a shipwreck target 15563, who subsequently shared the introductory sonar imagery with like Brennan and James Delgado at Search Incorporated. It's a private archaeology firm who spent a while, many months and years researching this particular target based on what they saw. And then, of course, a few months ago, opportunistically, we were able to partner with both to make an ROV dive as a part of our ROV shakedown cruise to 15563. It's hard not to mention our partners at Global Foundation for Ocean Exploration. They're our ROV pilots who conduct these missions, and they were able to capture high-resolution video to fully document this wreck site. It's found in 1,830 meters below the Gulf surface. And what was found was a largely buried shipwreck with a few number of highly significant diagnostic artifacts. We found what was clear to be a stove, if you will. It could possibly be a Triworks for rendering whale blubber into oil. There's a small kedge anchor that rests nearby with a larger bower anchor at the opposite end of the site. And based on the existing data in the historical research led by Search and others, the evidence suggests that this shipwreck 15563 was a whaling ship lost in the Gulf of Mexico while whaling, largely within the first half of the 19th century. Of course, with whaling itself, decades of historical research has been done with the incredible ship logs that are present with these voyages, and there was only one that was lost in the Gulf of Mexico, and that was the brig Industry of Westport, Massachusetts. Now, Industry was very significant in whaling history and maritime heritage in itself. It has powerful African-American and indigenous whaling connections, including the family of the most famous African-American mariner of the early 19th century, Paul Cuffey, whose son was a member of the crew on Industry, as were other family members and neighbors. And of course, there were some, 200 whaling voyages in the Gulf, all documented, and we have extensive records, and Search has led the efforts to read these various logs, and based on what we see, 15563 has a lot in common with Industry that allowed the research team to identify this shipwreck target as such. The wreck's hull form, the sole use of iron fasteners and fittings for cable for the anchors, the specific style of anchor certainly points to the first quarter of the 19th century, including rigging that held the mast in place. Overall size, the wreck is largely the same size as Industry, and its hull form is consistent with a small tonnage whaler like Industry. The wreck was two-masted, which matches up well. There's no evidence of copper sheathing to protect the hull. This was kind of a big thing where Industry wasn't copper sheathed either, and its logbooks and newspaper references really refer to its leaky nature as a result of marine organisms eating its unprotected hull. The wreck is 83 miles from where Industry, which was still adrift in water logs after a storm in May of 1836, it was actually boarded by the crew of a fellow whaler, Harmony, out of Nantucket on June 3rd, 1836. So Harmony comes alongside, salvages a whole bunch of items, including barrels of oil, and then leaves. And you can chart where that happened, where that boarding happened, and based on kind of weather patterns and traditional Gulf looping currents, where Industry may have rested and where it was found was certainly matched up with that analysis. It lies on the seabed northeast of the last located location, the last recorded location. And we compare Industry, and part of why I included it here was comparing Industry with the Monterey wrecks, where we're finding sand glasses and medicine bottles, strikingly empty, where so many other wrecks in the Gulf are filled with these artifacts. The wreck's missing an anchor. It's missing, lots of portable artifacts. Documented artifacts include, of course, there's a cask outlined in the silts, 2 anchors, the iron camboose, bottles. But Harmony's captain reported that they took 230 barrels of oil, parts of sailing, rigging, chain cable. One of the bow anchors was taken. Now, there's very little silt covering the wreck, as you can see from what is down there. So it's likely that the lack of artifacts are due to salvaging and not burial. A note about the camboose or the stove. It's not laid out as a regular stove. It has the layout of a whaling Triworks used to render whale fat into oil by extended high temperature boiling. These are sort of large, large spherical pots that really would be running all day. And you can see the fire bricks that are surrounding that camboose designed to keep heat off the deck after intense prolonged heat as they were alongside whales. And sort of its unique configuration was certainly one of the most important pieces of evidence that it's likely the wreck of a small whaling ship. But more often than anything, right, above all, out of the 214 documented whaling voyages in the Gulf between the late 18th and late 19th century, only one ended in shipwreck, and that was industry's last voyage in 1836. So pivoting just a bit from marine archaeological investigations aboard OceanIS Explorer and other NOAA assets, there's another way that ocean exploration is able to really advance marine archaeology, and that's with its ability to support or conduct, together with OceanIS Explorer, an average of 450 days at sea each year. And that's with our competitive grants program. Each year, funding notices on thematic areas are released, and they align with NOAA and ocean exploration missions. Typically, these include exploration, maritime heritage, and technology. And of course, grant proposals are peer evaluated by ocean science experts in the 3 thematic areas. Their projects are evaluated and ranked on mission relevance of the proposed projects to NOAA and NOAA Ocean Exploration's mission, scientific, technical merit, the overall qualifications of applicants, project costs, and outreach, education, diversity, and inclusion components. A quick note here, our fiscal 23 notice of funding opportunity was released on 25 March with a short 2-page pre-proposal due 24 May. Our grants program manager, Dr. Adrian Copeland, has a recorded webinar on this notice of funding opportunity that's available online on our website. You can follow this link, or I encourage you to reach out to me for more information here. My contact information will be here at the end of the presentation. But how marine archaeology fits into this certainly is one of the 3 thematic areas of principal interest. Our grants program is domestic in nature, funding domestic, academic, federal, non-federal, state, private, philanthropic efforts, but it's international in practice. And shown here are the 100 archaeology-focused projects funded by ocean exploration from fiscal 2002 to fiscal 2022. It's important to know this geographical distribution of projects here, where if you can imagine, some of the expeditions that you've seen just so far can represent just one of these expeditions. And so there's incredible science, and ocean exploration is leveraging the expertise of many professionals in the field that together, we are pushing these frontiers and continuing to map unknown parts of our ocean and discover significant parts of our shared underwater cultural heritage. One such project that was funded through our competitive grants program was a project funded in our fiscal 21 funding cycle with private industry company Sunfish Incorporated and Sea Alaska Heritage. And it was a paleolandscape study that identified the 120-meter isobath targeted as the ancient shoreline during the late Pleistocene, early Holocene area, time period when humans may have been migrating into North America via the Aleutians, the Gulf of Alaska, and into Southeast Alaska, where this study is focused. There's tangible evidence of their presence should be preserved in submerged caves and rock shelters at that isobath, which was the ancient shoreline. And to learn more about how and when people migrated to the Americas, this team is set out to search for evidence of human occupation on the continental shelf of Southeast Alaska in this area that has not been accessible to humans for over 10,000 years. Using the Sunfish autonomous underwater vehicle, which is designed specifically to operate in complex 3-dimensional undersea environments, and with a team of cave divers led by Jill Heinerth, The team plans to explore, map, and collect sediment samples from submerged caves and rock shelters. It will then analyze the data and samples collected to further inform our understanding of the past, both human and environmental. So it's a 2-year project. Year 1 is going to focus on on remote sensing surveys, specifically towed side scan surveys in this part based out of Craig, Alaska, which is on the western side of Prince of Wales Island. And year 2 is more target development with sunfish and the cave diving team. But perhaps most important is that the project is led by co-PI, Sea-Alaska Heritage Institute, Dr. Kelly Monteleone and Dr. Rosita Worrell. Sea-Alaska is an Alaska Native corporation representing many local tribes in Southeast Alaska. So it's an incredible partnership, being able to work with private and Alaska Natives to be able to fund this project and see the incredible results that are coming soon. It's a great transition to another part of this portfolio, which is the National Historic Preservation Act of 1966. Every single project that ocean exploration funds is analyzed before fieldwork begins to ensure compliance for along several important legislative pieces, including the National Environmental Protection Act and the National Historic Preservation Act, among others. And due to its mission scope, certainly in close distance to shore, the Sunfish and Sea-Alaska project was of course identified as one where additional efforts needed to be made to encourage communications and project collaborations with traditional knowledge holders in Southeast Alaska. And these efforts are informed and in compliance with Section 106, which states that federal agencies must consider effects of undertakings on historic and traditional cultural properties. Of course, this includes also grant funding federal agencies where we're not doing the work ourselves, but as the grant funder, we certainly fall into this, where we need to make sure that projects that are getting funded by our office are meeting these requirements. And it materializes, right, in many rewarding ways: consultations with state historic preservation offices, tribal historic preservation offices, indigenous communities, corporations, and associations everywhere we operate. Really through, on the indigenous side, relationship building with federally recognized both and non-federally recognized tribes. And of course, humbly forever learning about ways to increase efficacies of ocean science communications and partnerships with traditionally underrepresented and indigenous communities. It's one of my favorite parts of my responsibilities at Ocean Exploration, and we're lucky to learn from experts, many of which we haven't been able to connect yet, but agencies and programs like UCAR's Rising Voices are leading the way. And as a federal agency that's looking towards increasing our scope and our ability to network with traditionally underrepresented and indigenous communities, leveraging those partnerships is something that is a bright part of my day, and something that Ocean Exploration is committed to. And in the office, diversity, equity, inclusion, and accessibility, DEIA is a huge part of what we do, really in every facet, not just in our projects and where they're operating, but having an inclusive office culture with a DEIA working group, strategic plan, wellness surveys, et cetera, making opportunities more accessible. Ocean exploration really is about access, is about exploration, some of these far-reaching places of the EEZ and other parts of the deep ocean, but encouraging communications with students, traditionally underrepresented groups in marine science, and connecting them via the VSAT-enabled telepresence that specifically NOAA Explorer features is a huge part of what we do. Supporting marginalized group members at sea, creating a safe and inclusive environment at sea, and welcoming various backgrounds and certainly younger students aboard through our really rigorous, intensive internship program. And I mean that in the way of its breadth, all kinds of opportunities to be able to be engaged, to be involved. And it's something that the office takes a lot of pride in, and it's something that has only made our office better and stronger and more effective at communicating ocean science. And it's hard to mention, the work that ocean exploration is doing, specifically on the marine archaeology front, without giving a nod to some incredible CPAESS scientists that I have the pleasure of working with just about every single day. And CPAESS presence in ocean exploration is growing, and it's my pleasure to introduce Krista, Rachel, and Ashley, who I work closely with and are all making valuable contributions to how ocean exploration shares its science, educates the public, and informs biological research priorities for our office. So with that, I might close up shop here and open it up for any questions.
Thank you so much, Phil. This has been fascinating, really cool, something that people think about but don't know the details too. So it was just, we really appreciate you giving us a glimpse into that. So now we're going to begin the Q&A portion of today's seminar. I'd like to direct everyone's attention to the QR code that's on your screen. Please enter any of your questions for our speaker. And while you're doing that, I'd like to invite you to attend our next seminar on Wednesday, May 18th, with CPAESS scientist Neil Jacobs, who is serving as a Unified Forecast Chief Science Advisor in NOAA. He will be speaking on the Unified Forecast System. And it looks like we have a question for you. If you bring artifacts to the surface, what happens to them after you study them?
It's a great question. When we speak of material culture and excavation and recovery of artifacts, very rarely does it happen anymore. There was a time in archaeology when science was done by recovery and study and conservation. And really in the last 30 years or so, there's been a serious paradigm shift towards in situ preservation, or preserving and documenting things without disturbing them on the seafloor. And principally, that relates to cost and ability to preserve material culture for generations to come. Artifacts underwater, to a certain degree, are preserved. They're impregnated by seawater. They're stable in their environment, and many times have been underwater submerged for decades, if not centuries. And so once you remove an artifact from a status like that to open air and oxygenate the surfaces of individual artifacts, there's a big risk. There's a big risk in conservation, and it requires a lot of money, a lot of expertise, and certainly a lot of long-term planning. I had a professor who always highlighted, you can never undergo any kind of excavation unless you have really a stand-up permitted plan and what you're going to do with this thing 30 years, 40, 50, 60 years after you bring it up. Otherwise, it's not worth it. So so I can say that, ocean exploration from an in situ, non-disturbance archaeological survey method, by being able to take high resolution video, that's how we study a lot of these artifacts in deep water. There are natural and geological, biological resources that do get recovered for study, but from an archaeological standpoint, it's a very, very, very rare occurrence where archaeology materials are brought to the surface.
Thanks, Phil. Also, thank you for the shout out to our coworkers at the NOAA's Office of Exploration, and also for the Explorer and Training Program. CPAESS loves being able to participate with them and manage that. I have, I guess, another question for you, and that is, you touched upon it a little bit, but it's about the process of deciding what archaeological sites you get to investigate. Is it purely through the grant process that you outlined, or do you just have partners saying, hey, I heard you guys are going to be there. Can you check out this site for us, which is pretty close, or how does that work?
That's a wonderful question, Dawn. And so everything you just mentioned, you answered your question, right? Principally, if our game is identifying and exploring deep water habitat that's relatively unexplored in the US EEZ, there are shipwrecks in these areas. So a lot of data is collected, and prioritizations are made based on discoveries that occur, under our watch, if you will. That's kind of one category where we can say, hey, this is super significant based on what we've seen across our acoustic data and analysis. There's what you mentioned about partners saying, hey, listen, we've got this target. It's in the Gulf of Mexico. Looks like you might be close. Oftentimes, those multi-agency efforts really shine quite bright, as you can see through, I'm sure, some of the media coverage, specifically through industry and the data that I shared, with that collaborative agreement with Search and BOEM and others. And then the other part of that, Dawn, is our grants program, where we do fund projects that are set out to explore and discover not just targeted significant underwater cultural heritage, but also run across those significant sites, where then follow-up academic research and planning and documentation is then prioritized based on what comes from a lot of those projects. So it's all three, and they all have different flavors, but being able to be engaged with the archaeology community at large, to be able to make significant discoveries that we all benefit from and can all learn from is it's a great part of it.
Thanks very much for that, Phil. It looks like we have another question. Is climate change affecting, I think, these archaeological sites, and if so, how?
Wonderful question. I'm glad it was brought up. It certainly harkens back to some past life work in coastal environments, specifically up here in northern Lake Huron, where climate change is having effects on underwater cultural heritage, and certainly in the liminal transition zones between 0 and 30 meters, if you will, where really heavily advancing and retreating water levels are eroding traditionally protected archaeological sites out of riverbanks, out of sandbeds, moving archaeological sites underwater physically, with increased ice years, decreased ice years up here in the Great Lakes. Heritage is at risk, and climate change is a big part of it. It's a huge part of the industry, of archaeology, of the science. So if you're interested in learning more, please, I encourage you to reach out to me. There's a lot more out there on this topic. So great question.
I would encourage anyone who is watching this right now, if you have a question, please get it in. Phil, is there anything else that you would like to add where you're like, you know what, this is something that I really wish people who are interested in the science knew about?
Yes, there is, Dawn, and it's certainly ways to get involved. Ocean Exploration and other agencies really pride themselves on abilities to connect with shore-based scientists, to connect with the public. Heritage and archaeology isn't something that we need to just read about in newspapers and magazines. There are ways to connect, to be involved. And that's for everybody. So I encourage you to reach out to me if you're interested in learning more about underwater archaeology, what the field is like, or ways in your specific areas where heritage work or archaeology is being done on a federal, state level. It's a small enough community where we're all working together to promote awareness of these incredible places. So I think we can leave it at that.
Awesome. Thank you so much. Well, I guess I would just like to thank you so much for coming or for presenting to us, Phil, and for everyone who's come to the CPAESS Discovery Seminar. And Phil's talk is going to be recorded, and you'll be able to see it on our YouTube page. There's a link to it on our CPAESS website. And Phil, our sincere thanks for sharing your important research with us. And I'd also like to thank Brett Batterman of UCAR Multimedia Services for his assistance. And I hope that everyone comes back for May 18th for our next seminar. And thank you so much, and good afternoon, everyone.